Top 20 Mechanical Engineering Interview Questions and Answers. Welcome to our channel. In this video, we'll walk you through the top 20 mechanical engineering interview questions and answers to help you prepare confidently for your next job interview. Whether you're a recent graduate or an experienced professional, these answers will give you a solid foundation to showcase your technical knowledge and problem-solving skills. 1. Tell me about yourself and your background in mechanical engineering. I hold a degree in mechanical engineering with hands-on experience in design, analysis, and manufacturing processes. During my academic years, I participated in projects involving heat exchangers and stress analysis using SolidWorks and ANSYS. I completed an internship where I assisted in optimizing pump systems and production lines. I enjoy solving complex problems and applying engineering principles to create efficient, real-world solutions. I'm highly organized, detail-oriented, and thrive in collaborative environments. My background reflects a solid foundation in core mechanical principles and a growing expertise in CAD tools and mechanical systems. 2. What are the fundamental laws of thermodynamics? The 4 fundamental laws of thermodynamics govern energy and heat flow. The Zeroth law states that if two systems are in thermal equilibrium with a third system, they're in equilibrium with each other. The first law is the law of energy conservation. Energy can't be created or destroyed, only transformed. The second law states that entropy, or disorder, in an isolated system always increases, indicating the direction of energy flow. The third law asserts that as temperature approaches absolute zero, entropy approaches a constant minimum. These laws form the backbone of energy systems in mechanical engineering. 3. Can you explain the difference between stress and strain? Stress and strain are mechanical properties that describe how materials react under force. Stress is the internal force per unit area within a material caused by an external load, typically measured in pascals PA. Can be tensile, compressive, or shear. Strain, on the other hand, is the deformation or displacement a material experiences due to applied stress, expressed as a dimensionless ratio. In simpler terms, stress is the cause, force applied, while strain is the effect, deformation. Understanding both is essential in material selection and structural analysis. 4. What is the difference between a heat engine and a heat pump? A heat engine converts thermal energy into mechanical work by absorbing heat from a high-temperature source and expelling some to a low-temperature sink. Examples include internal combustion engines and steam turbines. In contrast, a heat pump does the reverse. It consumes mechanical work to transfer heat from a colder area to a warmer one, often used in heating and cooling systems. While heat engines focus on extracting useful work from heat pumps aim to control temperature efficiently by moving heat against its natural flow direction. 5. Describe the working principle of an internal combustion engine. An internal combustion engine, ICE, generates mechanical power by burning fuel-air mixtures within the engine cylinders. The process involves 4 main strokes: intake, where air and fuel enter the cylinder; compression, where the mixture is compressed; power, where the mixture ignites via spark or compression, forcing the piston downward; and exhaust, where combustion gases are expelled. This cycle repeats rapidly to produce rotational energy that powers vehicles and machinery. The ICE remains a key innovation in transportation due to its compact design and energy-dense fuel source. 6. What is entropy and why is it important in thermodynamics? Entropy is a measure of disorder or randomness in a system, indicating how energy is distributed. In thermodynamics, it helps explain the direction of natural processes. According to the second law of thermodynamics, in an isolated system, entropy never decreases. It either increases or remains constant. This concept is critical in assessing system efficiency, as real processes always involve energy dispersion. Engineers use entropy to determine irreversibilities in systems like engines, refrigerators, and turbines, ensuring optimal energy utilization and minimal waste. 7. How do you calculate the efficiency of a machine? Efficiency is the ratio of useful output to total input, expressed as a percentage. It's calculated using the formula. Efficiency % equals useful output energy / input energy times 100. No machine is 100% efficient due to friction, heat loss, and other energy dissipations. Measuring efficiency helps identify areas of energy loss, optimize performance, and reduce operational costs in machinery and processes. 8. What is the difference between laminar and turbulent flow? Laminar flow is smooth and orderly, where fluid particles move in parallel layers with minimal mixing. It occurs at low velocities and is characterized by low Reynolds numbers, typically less than 2000. Turbulent flow, on the other hand, is chaotic, with irregular swirls and eddies, occurring at high velocities and high Reynolds numbers, typically greater than 4000. Understanding the type of flow is vital in designing piping systems, turbines, and aerodynamic structures, as it affects drag, heat transfer, and energy efficiency. 9. Explain the concept of fatigue in materials. Fatigue is the progressive and localized structural damage that occurs when a material is subjected to cyclic loading. Even if the stress levels are below the material's ultimate strength, repeated loading can cause cracks to initiate and grow over time, leading to sudden failure. Engineers use SN, stress number, curves to predict a material's fatigue life. Preventing fatigue involves improving surface finish, avoiding stress concentrations, using better materials, and conducting regular inspections. This is crucial in aerospace, automotive, and machinery components. 10. What are the types of fits used in mechanical design? In mechanical design, fits describe how tightly or loosely two mating parts, like a shaft and hole, connect. There are 3 primary types. 1. Clearance fit always leaves a gap between parts. Easy assembly, e.g., fan shaft. 2. Interference fit parts are forcibly fitted, often requiring heating/cooling, e.g., gears on shafts. 3. Transition fit may have a slight clearance or interference depending on tolerances. The right fit ensures functionality, reliability, and performance based on the application's load, temperature, and operational environment. 11. Describe a time when you solved a mechanical failure. During my internship, a conveyor system kept halting due to overheating bearings. I conducted a root cause analysis and found the lubrication intervals were insufficient, and the alignment was off. I proposed a revised maintenance schedule and aligned the system properly using dial indicators. This reduced downtime by 40% and improved operational reliability. I documented the solution for future reference. This experience taught me the importance of systematic troubleshooting, preventive maintenance, and clear communication between engineering and operations teams. 12. What is the difference between CAD and SAM? CAD, computer-aided design, involves designing 2D or 3D models of mechanical components using software like AutoCAD or SolidWorks. It helps in visualizing, simulating, and optimizing designs before production. CAM, computer-aided manufacturing, on the other hand, uses those CAD models to automate the manufacturing process, often controlling CNC machines. CAM ensures precision and reduces human error. While CAD is used for design and analysis, CAM translates those designs into physical products. Together, CAD and CAM streamline the product development lifecycle. 13. Which software tools are you proficient in? AutoCAD, SolidWorks, etc.? I also have experience with ANSYS for structural and thermal analysis, and MATLAB for numerical modeling and automation tasks. In addition, I've used Fusion 360 for integrated distinct manufacturing processes and Creo for parametric modeling. These tools help in improving design accuracy, visual communication, and analysis, making me efficient in handling diverse mechanical engineering tasks from concept to implementation. 14. How do you ensure accuracy in your mechanical designs? To ensure accuracy, I follow a structured design process. Starting with clear requirements, conducting thorough calculations, and creating detailed CAD models. I validate designs through simulations, stress, thermal, motion analysis, and peer reviews. I always cross-check dimensions and tolerances, and use standardized parts whenever possible. Proper documentation and adherence to design standards like ISO or ASME are critical. Additionally, I iterate based on feedback from prototyping or manufacturing, ensuring real-world performance aligns with the design intent. 15. What is the function of a flywheel in an engine? A flywheel is a mechanical device used to store rotational energy and maintain consistent angular velocity in an engine. It absorbs excess energy during the power stroke and releases it during non-power strokes. Intake, compression, exhaust, ensuring smooth engine operation. Flywheels reduce vibration, stabilize torque delivery, and help start the engine by storing energy from a motor or crank. They're essential in systems where energy balance and stability are important, such as automotive engines, power presses, and energy recovery systems. 16. Describe different types of gears and their applications. Common types of gears include spur gears, straight teeth used in simple machinery and transmissions. Helical gears, angled teeth, quieter and smoother, used in automotive gearboxes. Bevel gears, conical shape, transfer motion between intersecting shafts, used in differential drives. Worm gears, screw-like shape, used for high torque and speed reduction, common in lifts. Planetary gears, compact and efficient, used in automatic transmissions. Each gear type has specific strengths, chosen based on speed, load, and directional requirements. 17. What are your favorite areas in mechanical engineering and why? I'm particularly drawn to mechanical design and thermodynamics. I enjoy the creativity and precision involved in transforming concepts into functional components using CAD tools. Thermodynamics fascinates me because of its relevance in energy systems, engines, and sustainability. Both areas allow me to apply theoretical knowledge to solve real-world problems and optimize system performance. I also have a growing interest in automation and robotics, as it represents the future of manufacturing and innovation in mechanical engineering. 18. How do you stay updated with recent industry developments? I regularly follow engineering journals like ASME Mechanical Engineering Magazine and online platforms such as Engineering.com, GrabCAD, and LinkedIn groups. I subscribe to newsletters, attend webinars, and watch industry-focused YouTube channels. I also engage in online courses from platforms like Coursera and edX to sharpen my skills in emerging areas like additive manufacturing and renewable energy. Staying updated helps me remain competitive and ready to adopt new tools and practices in a rapidly evolving engineering landscape. 19. How do you prioritize safety in mechanical projects? Safety is a top priority in every phase of mechanical engineering, from design to implementation. I begin by identifying potential hazards through risk assessments and failure mode and effects analysis, FMEA. I ensure compliance with safety standards, like OSHA or ISO, and integrate safety features in designs. During manufacturing or testing, I advocate for proper PPE usage, training, and maintenance schedules. I believe safety isn't just a requirement. It's a responsibility that ensures the well-being of everyone involved. 20. Why should we hire you for this mechanical engineering position? I bring a strong foundation in core mechanical principles, hands-on experience with design and analysis tools, and a problem-solving mindset. My ability to communicate technical ideas clearly and work well in team settings makes me an asset. I'm committed to continuous learning, adaptable to new technologies, and eager to contribute to innovative projects. With a balance of technical skills and enthusiasm, I'm confident I can add value to your team and help drive engineering solutions forward. Thanks for watching. We hope these top 20 mechanical engineering interview questions and answers have boosted your confidence and helped you understand what to expect. If you found this video helpful, don't forget to like, share, and subscribe for more career tips and interview guides. Got questions? Drop them in the comments below. We'd love to hear from you. Good luck with your interview.